there is perception that composite core is not bendable, let alone you add another layer onto the composite with the relatively thick layer of aluminum encapsulation. What we have to keep in mind is when you bend a material, it is the tensile strain and the compression strain that you have to be concerned about. And you need to make sure that the bending does not exceed the tensile strain and also the compression strain. Composite core normally feel stiff. And we also talked about in these type of unidirectional composite, they have exceptional fiber dominated property, strengths namely. Their compressive strength is matrix dominated. It is relatively low. It's only about 60 to 70% of the tensile strength. So when you bend it, you have equal magnitude of compressive stress compared to the tensile stress. And when your tensile strength is high, when your compression strength is low, you will always have the compression failure under the same bending radius. So in the field and in the real conductor application environment, during installation, you oftentimes don't have tension in the conductor. And when you have those situations, you have to be very careful about compression failure because you don't have the benefit of compressive stress or stretching or I should say you don't have the benefit of the tensile load on the conductor to offset the compressive stress that might be developing from bending. So in installation, we have to be very careful about sharp edge or small radius or change in directions during installation, because that is when the conductor is the most vulnerable. And this is also why the first generation advanced conductor require perfection from linemen to follow every step in the installation according to prescribed procedures. With TS, we have that pre-tensioning. And so even though the conductor itself may not be under tension, because you have situations where you don't have tensions, you are doing conductor installations, you have a built-in protection for you. That's where the robustness comes in. And when the conductor, however, is in service, you always have tension on the conductor, even when the conductor having a slope, from saggings. That compression failure will no longer exist. So you don't have to worry about that. Even with our aluminum encapsulation, we don't necessarily need that protection mechanism anymore once it's energized. Once the line is installed, that you will always have tension on the conductor throughout its deployment life. The bending of a composite material, it is not obvious that conductors like ours can be bent. It's actually more bendable than a bare conductor because we have that built-in pretension to allow you to have even more extreme bendings, including sharp edge, that is not going to snap the conductor. You will have a graceful bending curvature with full integrity of the composite core preserved because of the pretension mechanism in the carbon composite core.